Okay, you're welcome to another solution to WAEC past question 2024. We're going to be reading this question and then I'm going to be telling you where you want to kind of find it in case you want to further read it in other textbooks. So follow me as we electron of mass M and charge E moves through an electric field of potential difference V0 with a speed V. Show that the developed length associated with the electron is given by this, where H is the Planck's constant. So what they're asking us to find is to prove this equation. You find this in your modern physics, a Planck constant, and the Broglie equation. We use it in finding the wavelength of an atom, the microscopic level. So let us dive in already. Okay, so from the Broglie equation, let us just from the Broglie equation, the Broglie wavelength, that is equal to H all over mv, and this is equation 1. Okay, we're going to be starting at H is the Planck constant. Planck's constant. M is the mass of electron. So we are going there gradually, and then we now know that V is the speed. Okay, now we know that from kinetic energy, when we are taught in mechanical energy and types of energy, we know that kinetic energy Ke is given by half mv squared. Okay, the kinetic energy of an electron is always given as E V sub naught. Of course, E is the electron, while V is the stopping potential. So let's just write it. V naught is the stopping potential. So we know that this is the stopping potential. We are going to be equating both this equation and this equation. So we can say here should be I, here should be II. So equating equation I and II, we know that half mv naught. Okay, so from here, making V the subject of the formula, we're going to have V squared is going to be equal to 2 Okay, so if now we want to square, let us make V now to stand alone. Now squaring both sides, we're going to be having V will now be equal to, so now V will now be equal, this becomes our equation 2. Let's do from the beginning and getting at the end of the day. So we now say putting equation 2 into 1. We now have that equation 2 we're going to have lambda will be equal to H all over, putting everything inside, M will be outside, the square root of 2EV0 all over. Now we have gotten this. If you want to now square it all together, putting this guy inside, you're going to be having lambda equal to H all over M squared times 2EV0 all over M. So we are making some progress here. So from here, the next thing we are going to by this, and if we do so, we are going to be having this, which is equals to H all into 2EV0, and at the end of the day, we have this as our solution. Now you can now compare with the equation that was given, that we should take this, we should find this as what we have gotten here. Good luck to you. If you find this video very educative, please do well to subscribe and share to your friends so that they will come and upload more videos on what you need us to work on. Thank you.